Hello everyone, I'm Prashant and welcome back to my Java concurrency playlist. In this video, we are diving into basics of threads, an essential concept for mastering concurrency in Java. Why threads are important? Now you might wonder why are the threads so crucial in programming? Well, think of your computer or your phone. Many tasks are running simultaneously. For example, you are watching this video while your system might be downloading files, syncing cloud storage, or running background updates. This ability to handle multiple tasks at once is powered by something called concurrency. And in Java, threads are at the heart of it. Threads allow us to perform tasks in parallel, improving efficiency and responsiveness. For instance, a user interface can remain smooth and interactive while in background task processes data. Understanding threads is the first step to writing efficient, high-performing applications. What is thread? Introduction to threads. So what exactly is a thread? In simple terms, a thread is the smallest unit of execution within a program. It's often referred to as a lightweight process because it shares the same memory space with other threads within a single process. Unlike traditional processes that have their own separate memory. Thread versus process. Let's break this down further by comparing threads with processes. A process is like an independent application running on your computer. Each process has its own memory space and resources, which makes it isolated but also resource intensive. A thread, on the other hand, is a smaller unit within a process. Multiple threads of a single process share the same memory and can communicate with each other more efficiently. This shared memory makes thread faster to create and switch between. But it means you need to manage synchronization carefully to avoid issues like race conditions. Think of a process as a company and threads as the employees within that company. They all work together towards a common goal, but share the same office space. Why use threads? So why do we need threads in the first place? There are three key reasons. One is parallelism for performance. Threads allows us to perform tasks in parallel. For example, if you want to process a large data set, splitting the work across multiple threads can significantly reduce the time it takes to complete. Responsiveness in applications. In GUI applications, threads are essential for keeping the user interface responsive. For example, in a video player, one thread can handle playback while another handles the downloading subtitle in the background. Efficient resource sharing. Since threads share the same memory space, they can work together more efficiently than separate processes, making them ideal for the tasks that require frequent communication or shared data. Now that you understand what threads are and why they are so powerful, let's take a closer look at how threads behave during their life cycle. This will give you a solid foundation before we dive into the coding. Thread lifecycle. Thread's life stages from creation to their termination. Introduction to thread lifecycle. To fully understand how threads works, it's important to learn about their lifecycle. A thread in Java goes through several stages from its creation to termination, and understanding these stages will help you manage thread behavior effectively. Let's explore each stage of this thread lifecycle. So, first one is new. When a thread object is created by using new thread, it enters a new state. At this point, the thread hasn't started yet. It's just an object waiting for the start method to be called. When we are calling thread T or any other thread name is equal to new thread, the thread is in the new state. Runnable. When you call the start method, the thread moves to the runnable state. In this state, the thread is ready to run but might not immediately start executing. It depends on the thread executor, which decides which thread gets the CPU time. When we call thread or any other thread name dot start, that then that thread moves into a runnable state. Running. Once the thread scheduler picks the thread, it enters a running state. This is when the thread starts executing the code inside the run method. Remember, this transition from runnable to running is controlled by the operating system's thread scheduler. So you don't have direct control over it. Blocked or waiting. Sometimes a thread may need a pause temporarily. For example, it is waiting for the resource or any other thread to complete. In this case, it enters a blocked or waiting state. But there is a difference between a blocked and waiting state. In a blocked state, it generally happens when two threads are competing for a synchronized block or method and only one of them gets the lock on that. So the other thread go into the blocked state. Once it acquires the lock onto that synchronized method or block, it again come to the runnable state and then it gets a CPU and move to the running one. In the waiting state, it generally happens when we are calling for the another thread to get completed, then the current thread can start executing join method, or we wait for the another thread. Timed waiting. Timed waiting is another variant of waiting. It happens when we call the sleep method, wait with time, park nano, or park until. And the terminated state comes when the run method completes or the thread is stopped. It enters the terminated state. A terminated thread cannot be restarted. A demonstration of code will be a good idea to understand about the thread lifecycle. So let's update uh, our sheet with the thread basics in Java that we are continuing this, and let's go to this design to understand the stages. So we are having to demonstrate it, we need two threads because to show the stages, two threads are required because when one thread goes into the sleep state, we cannot print its state. So we will be needing the other thread which can demonstrate the stage of that particular thread. So here we are having two threads. One is parent thread, one is child thread. Parent thread will be creating the child thread and it will be they both of them will be printing their stages while on uh, in whatever the stages they are. So we will begin with creating the parent thread. We will initiate the parent and we will start the parent. We will initiate the child parent class. We will start that and we will be running this particular parent thread will be sleeping for 1 second and child thread will be sleeping for 2 seconds. So when our parent thread wakes up, we will print the stage of the child thread. So it is supposed to be the timed waiting. Then we will call the join method here. Child.join will be called here, and after that it will be waiting for thread to get completes, and when the 2 seconds will be over, our parent thread will be in a state of waiting. So we will sleep for 1 more second in the child thread. We will come back and then we will print the stage of the child thread that will be terminated. And once the child class gets over, we print the stage, it will be terminated. So here we will see the stages that will begin with the new. When we call new thread, when we will start this thread, this stage will change to uh, runnable. When we sleep for some duration, the thread will go into the timed waiting. Then when thread will wait for another thread to complete, till that time the current thread will be blocked. So we will be in a stage of waiting. And then once the thread execute finishes its execution, or stop method is called on that, then we will be in a stage of terminated. The one stage that is not being demonstrated here is blocked. We can create another program in the next video to show this stage. So here we are starting with run. Then we will be having a runnable. After starting that method, it will start another child thread. Then its state will be new, then runnable. It will go for the sleep, and both threads will be sleeping. When it's wake up, it check its state, so it will be in the timed waiting. Then this method will call join and waiting for the child thread to get completed. After 2 seconds, it will check the state of the parent um, thread. It should be waiting. Then after 1 second, this particular thread completes, the child thread gets complete. Then after that, we will check the state of our child thread. It should be terminated here, and the thread, because it is running, the parent thread, it will be runnable. And once the thread 1 completes its execution, it will be again shown as terminated. To demo the same by using code, we will be writing two set of codes. In first code, we will be showing the thread states which does not require two threads to execute. Then we will be writing a relatively more complex code where we will be needing two threads, parent thread and child thread, to show the states. Those are not possible by using a single thread. So let's uh, uh, come to the coding part. So here we are having a thread states. We will be writing one package, that is single thread state, single thread state demo. Here we will be calling a main method. We will be creating one thread is equal to new thread, and we will be creating a runnable here that uh, will be doing some set of operation like thread dot sleep for 5 seconds, and we will be moving this uh, surround with try catch, and we will be printing the state of this thread while it will be executing. So first, system.out.println thread state when not started, and we will be writing thread dot get state, and after that we will be the main thread. We will start this thread, and also in the main thread we will be we will be sleeping for 1 second, and then after that we will be printing the state of this thread, so that should be timed waiting for 1 second, and after 1 second we will be printing the state of uh, our thread. For 1 second, then we will be waiting for this thread to complete, and then after that we will be printing the last stage. So we'll be writing thread dot join, and we will be printing the state after of thread. We'll printing the thread state thereafter. So um, after starting, so in the first state when we have not started, it should be in the new state. Just after starting, it should be in the runnable state, and once in the main thread we will wait for 1 second, and after waiting for 1 second we will print the state of the thread. It is supposed to be timed waiting, and then we will wait for the thread to get completed by using that thread.join, and after that we will print the state of the thread, so it's supposed to be terminated. Let's run this code and see the states. So we can see it's a new state, the thread is a new state. Once it is started, it is moved to the runnable state. When after 1 second, when the main thread waited for 1 second, and while the thread was in the sleep state, we can see the state as timed waiting. And once this thread gets over or completed its life cycle, it is now in the terminated state. So now we are able to see 4 states of thread, but unfortunately we cannot see the state of a thread when it is on join. So we will be using one more complex example, and we will be writing the code for it. So let's write down the package multi-thread uh, states. So for now we will be creating the parent runnable, child runnable, thread stage manager that will be having a main method and which will be creating the instance for us. And finally, we will be having a utility class to for the wait method to keep the code clean and also for printing the stage of the child and parent class. And it will be having the static methods. So let's implement runnable and start. Let's code for the child enable class. So here we can see we will be once this is created, we will be waiting for 2 seconds. We will be printing the state for thread parent thread, and then after that we will be waiting for 1 second. We will be printing its own state, and the job is done. So here for printing the state of the thread parent thread, we need the instance of a instance of this one. So we will be having a variable here, the thread actually. So thread private thread uh, parent thread, and we will be having a setter method for it, and we will be using it. So let's go one by one. We will be printing the state of the the child uh, the child thread. So yeah, let's write down the code for it. Print state. We can write a utility method for it. So public static void print state. We will be passing a thread here, and we will be passing if it is parent or child, so that we can keep some gap in the threads so visually it is more visible, and we can put down the message here if we want to write something. So first let's say write down the string that we are going to print. uh, Thread log will be a string dot format percentage s. So yeah, this will be a thread name having state percentage s, and we will be printing the message here. So let's write down the thread dot get state. Yeah, sorry, thread dot get name, uh, thread dot get state, and the message here. So we want to format it a bit. If it is parent, we want to align it on the left hand side. If it is child, then we want to align it a bit on right hand side. So if it is parent, we will simply write down the mess. We will print the log here, and else we will be printing a gap here, and we will be printing the thread log here. Return backslash tab dot repeat. We will repeat it um, 15 times. I think it should be sufficient. And one related problem, let's see what is the problem. We can import static. We have not given the parameter yet, so let's give this thread. So we will be giving that uh, thread dot current thread, and the second argument we have to give is parent. No, it's not. And we will be having the first statement after creation. And even we can actually remove that. Uh, we can import static, and once after this, what we gonna do, we will be sleeping for 2 seconds. So sleep for seconds 2. Let's create this method in the utility class. Because yeah, we have to convert the seconds into milliseconds, and let's handle the try catch. So yeah, let's, oh no, oh, static. Okay, we'll be waiting for 2 seconds, and after 2 seconds we will be printing the state of our parent. So we will be writing the parent thread here, that we will be getting by set parent thread true after 2 seconds. Then we will be waiting, then we will be sleeping for 1 second more, and we will be printing the last message, the last statement. Okay, so here this thread 2 will be done. Now let's come to the parent thread. Implements runnable. As we have to create a child runnable, so we should get a runnable as an argument here. So we have set the constructor for this, and yeah, we are good here. Let's see what we need to do is, yeah, here we cannot do anything, but we can, after the starting parent, we can print the state of it. So let's copy the message here, and because it is a parent, we will print it true. First statement after creation. Then we will create create a thread for child. Thread. We will pass a runnable here, child runnable, and we can write down the method return new thread, and here it is, child runnable. We will print the state of that child before starting it. It's supposed to be new. It is not parent, child thread before after initialization. And then we will start it. The child thread will start. Once the child thread is started, we will sleep for 1 second. After sleeping for 1 second, we will check the state of our child thread. So it is supposed to be timed waiting. After 1 second. Then after 1 second, we are printing the state of the child thread, and then we will be joining on the thread 2. So child thread dot join. So clean this code. I will be moving to another method. Uh, join child thread. Okay. So now this thread will be it. The parent thread will be waiting for the child thread to get completed. Once it is completed, we will print the state of our child and the parent thread itself, and we will be done. The join and now yeah, we are completed. Everything is done here, and now we have to come to the stage manager and just do the setup. So we will be creating a child runnable here because we have to pass the same into parent runnable. Parent runnable, parent runnable is equal to new parent runnable. We will pass a child runnable here. Now the child runnable, we have to set the parent runnable here. Oh, I'm sorry about that. We will set the parent thread. So yeah, okay. We will be creating the parent thread here, and that we will pass into the child runnable. New thread, parent runnable, and this parent runnable will be passed to child runnable dot set parent thread and parent thread. After creating the parent thread, uh, we can uh, print the state of it. Let's go to after start. First statement after initialization. Yeah, so we can print this state, and after that we have set the parent thread into the child runnable, and we can parent thread dot start, and we will be waiting for the the parent thread to get completed. So thread dot sorry, parent thread dot join, and yeah, we will use a try catch. Join parent thread. So we will be waiting for the parent thread to get completed, and after that we will print the state of the parent thread. It will not be the current thread, actually it will be the parent thread. The same here, we will be having a parent thread here. So let's run it and check the output of it. So let's see, the thread 0 is the parent thread because it is on the left hand side. The thread 1 is a child thread that is on the right hand side. So is having the state new first statement after initialization. So it is starting with new, then thread 0 after starting it goes into runnable state. So here we are having the runnable state. It started a new thread that is child thread, so it is in the new state. Then it runnable state. Time waiting. So after 1 second, so after 1 second, when we print the state of thread 2, so it is still in the sleep mode. So in the sleep mode, we are having the timed waiting state. So here we can see in the timed waiting, we are waiting for the sleep. Okay. So now after 2 seconds, thread 0 came into the waiting state. So after 2 seconds, we executed the join. We waited for the second thread or child thread to get completed. So it is in join state. So when it is in join state, in that case, it will be showing the waiting. So here we can see it is joining and it will be waiting. After that, thread 1 having the runnable state, the last statement, after that it is supposed to get terminated. Here we can see, so thread 0 is coming into the runnable. After the join, it start executing, and the thread 1 have the terminated state, and thread 0, that is the parent state, is now terminated. Okay, log message need to be changed, the last statement after initialization, and I think that's it. So last statement after initialization, and we are done with this code. A key takeaway here is that you don't have direct control over a thread moves from runnable to running. It is handled by the thread scheduler, which makes decision based on the factors like priority and system load. Next, let's see how to create and manage threads in Java with a real code example. Thread creation in Java. Now that we understand the thread lifecycle, let's move on to the creating and running threads in Java. There are two main ways to create threads in Java, either by extending the thread or extending the thread class or implementing the runnable interface. That we have already covered in our last video, so we will quickly check it and we will move to the next section thereafter. So starting with the extend the thread class. So extending the thread class, this is a simpler approach. By extending the thread, we can override the run method to define the task that will run on the thread. The method is best for simple cases where the thread task is tightly coupled with the thread class. However, Java supports only one single inheritance. So if your class already extends another class, you can't extend thread. So let's see the code that we have already gone through in our last video. So we are having a class, custom class extending the thread. We create the instance of the thread and we will call the start method. So it is important to call the start method rather than run. So if we will if we'll call the run method, the same execution will happen. It will not give any error, but the thing is, it will be in the same thread. For example, here, as I'm calling in main, so it will not create a new thread, but it will simply run in the main thread. So parallelism will not be there. And now let's move to the runnable interface. So let's look at this runnable interface approach. It is more flexible because it allows class to implement multiple interfaces that run tasks concurrently with runnable. You define the task in the run method and you pass the instance to the thread object. This is preferred if you need to share the same task across multiple threads. So if you have the class hierarchy and you don't want to extend the thread, it is more modular and can be used for more complex thread management tasks. So here you can see the code. We are having a custom runnable class. We are overriding the run method and it is must here. This run is optional, but definitely we should do that. But here without overriding the run method, because the run method is a part of the runnable. If we don't do that, we will get the error. So we will create the instance of the custom runnable, we will pass that into a thread and we will start it. So here, as it is extending the thread, so we cannot uh, extend anything, any other class. But here we have the flexibility of extending any other class because Java supports a single inheritance. So the thing is when to use each approach. So you can use the extend thread way when the task is simple and directly related to the thread class, and you don't need to extend any other class. You should use the runnable when you want to separate the task from the thread itself. You need to implement the multiple inheritance or work with existing class hierarchies, or if you plan to reuse the same task with the multiple threads. To summarize, both methods are useful, but it is important to pick the one that fits your use case. If your task is simple and tightly bound to the thread, extending thread is quick and easy. But if you need more flexibility or plan on sharing the task across different threads, Runnable is a way to go. Now that we have covered creating threads, let's take a look at some important thread methods and that can help you manage threads more effectively and efficiently in Java. Common thread methods, essential thread methods, start, join, sleep, and more. So now that we know how to create and start threads, let's explore some of the most commonly used methods in thread class. These methods will help you manage the behavior and lifecycle of threads effectively. So first start with start and run method. A start method is used for begin the execution of a thread. When you call start, the thread enters the runnable state and the JVM schedule sets for execution. For example, when you instantiate a thread is equal to new thread, and then you call the thread dot start thread, it creates a new thread. It is important to note that start can only be called once on a thread. If you call start on an already started thread, it will throw an illegal thread state exception. Run method. The run method contains the code that will be executed by the thread. However, you don't call run method directly. Instead, the start method internally invokes the run. Always override the run method when you create a thread, either by extending thread or implementing runnable. Join method. The join method allows one thread to wait for another to finish before proceeding. When thread A calls join method on thread B, thread A will pause until the thread B completes its execution. When we are having two threads, thread A and thread B, we call start method on both of them and then we call thread A dot join. In that case, the thread A will wait for thread B to finish before executing its own statement. This is helpful when you need to ensure that certain tasks complete before moving on. Be mindful of potential deadlocks if multiple threads are waiting for each other. Sleep method. The sleep method pauses the execution of the current thread for a specified period, giving other threads a chance to execute. It's a static method, meaning it is called on the thread class itself, not on an instance. For example, when we need to execute it, we will have to call thread and dot sleep. In this case, it is a static method, it is calling on the thread itself. Be cautious when calling sleep as it can throw an interrupted exception, so you should always handle it properly. Don't use sleep for a precise timing. For that, you may want to use the timers or schedule tasks. Is alive. Is alive method checks whether a thread is still running. It returns true if the thread has been started and has not yet finished executing. If we are having a thread A, we call the start. on this thread, and then after that we can use thread.isAlive. So isAlive will return true if the thread is executing right now has not finished its execution. This can be helpful for checking the status of a thread, especially in a multi-threaded applications where you want to ensure all threads are properly managed. Best practices and pitfalls. First, always call a start method to begin a thread, not run. Use join method when you need to synchronize threads to ensure one thread completes before another starts. Third, handle interrupted exception properly when using the sleep or other interrupted methods. Fourth, avoid calling sleep for long duration in a real-time application. Pitfalls. First, calling start more than once on a thread causes an exception. Second, forgetting to join threads when necessary can lead to a race condition or threads finishing out of order. Overusing sleep, the third one, overusing sleep can degrade performance and responsiveness. Fourth one, mismanaging thread synchronization can lead to a deadlocks or other concurrent issues. Summary. Understanding these threads methods and using them correctly will help you effectively manage multi-thread applications. Up next, we will explore synchronization techniques to ensure your threads can safely share resources. Now, we will see one code example to see how thread can help us improving the performance. So, in this section, we are going to implement a real-time example when we use thread to calculate the sum of an array concurrently. By splitting the array into two parts and using the two threads to calculate the sum of each part, we can improve efficiency, especially for our larger arrays. Let's walk through how threads can help improve performance in this case. So let's close all the tabs. So in this section, we are going to implement uh, the concurrent sum. Here we have an array of integers and we want to calculate the total sum of the elements. Instead of calculating the sum sequentially, we will break the array into two halves, assign each half to a separate thread. Each thread will compute the sum for its part and then we will combine the result to get the final sum. So in this code example, we are going to create a custom thread class. So we can create a class sum thread. It will extends the thread. This class and yeah, we will divide the array into halves and assign each half to a separate thread. We will start the thread and wait for them to complete using the join method. We will combine the results for both array to get the total sum. So in some thread, we will be having a private integer array. We will be having a private int uh, start index. We will be having a int and index, and we will be having private int partial sum. So we are going to expose one method. uh, First we actually have to initialize this with the array. start index is equal to start index and end index. And we also can mark every uh, variable as final apart from partial sum because we are going to calculate that. So because we are extending the thread, we will override the run method. In this run method, we are setting this partial sum as 0. We will calculate that. Uh, we will be having the start index, end index, this will, and we will be having partial sum plus is equal to array start index, the I, and we will be having this partial sum stored there, and we will expose one getter here for the partial sum. Okay, here we are done with the thread class. Now we will be having a concurrent sum class. Here we will initialize an array and we will do that in a main method, and we will be having int array is equal to 1 2 3 4 5 6 7 8 9 and 10. And then after that we will be having the int made is equal to array dot length divided by 2. We will create a two sum thread. Thread 1 is equal to new sum thread. We will be parsing array 0 mid, and we will be doing the same, changing some variable name. uh, mid is actually exclusive. Here in the end index it is exclusive, so we will be having that array dot length. And also we are going to start the two threads dot start. In a similar way, we will call this sun2 method and we will wait for that join thread 2 dot join, and we can add the exception to this particular main method, and we can calculate the total sum is equal to thread 1 dot get partial sum plus thread 2 dot get partial sum, and we are going to print this total sum. Let's run this code, and before running this code we actually can get the result by using n into n plus 1 by 2. So we are having n 10 here into 10 plus 1 divided by 2. So it's supposed to give us the answer, and it should match with the total sum. So let's run this. So yeah, we get the same sum as 55, and our total sum is also given us the 55. So yeah, if we change from 10 to 11, so we should get 56 as a result, and we can verify it. Yeah, 56 here. So here we can actually can understand about this code. In this, we are having a custom thread class, that is some thread. This extends the thread and has a constructor that accepts the argument array start index and end index, and its run method compute the sum, uh, the partial sum from the start index till the end index, and this index is exclusive. Means it if I'm having 0 as a start index and 5 as end index, then it will compute the sum of index 0, 1, 2, 3, and 4, not 5. So we are having a main class. We created a thread here. We created the mid of it, and then we pass this. Mid is exclusive here. Array.length is also exclusive. We compute these two threads executed the run method of their class, and after that when we started it, we joined it, we waited for those methods to get completed, we get the sum here, and we are throwing the interpreted exception for these two these join method call, and after that we are just printing after getting the partial sum from both of the threads, and it is giving us the right result. In today's video, we covered the basics of threads in Java, from understanding what threads are and their life cycle to creating and managing threads for concurrent tasks. We also saw how threads can significantly improve the performance when used for tasks like parallel processing, such as calculating the sum of an array. Remember, threads allows you to execute tasks concurrently, leading to more efficient use of resources, especially in a time-consuming operations. However, effective thread management and synchronization are a key to avoid pitfalls such as race condition and deadlock. So in the next video, we are going to the discuss understanding the runnable and callable interfaces. So I encourage you to practice by writing your own threads. Start with simple examples, calculating sum or processing different parts of collections in parallel. Experiment with creating multiple threads and managing them effectively. So by calling so yeah, thank you very much. Don't forget to like this video if you learn something new. Subscribe to my channel. It motivates me to create new videos, new content on Java concurrency and later on the other topics. Drop any question or feedback on the comments below. Happy coding.